Hello student and welcome back to Naz Academy Education. I hope you are all okay. So we see in this video work and energy exercise. Question number 1 A. Write detailed answer. Explain the difference between potential energy and kinetic energy. Okay. Answer. Kinetic energy and potential energy are the two forms of energy which any object of body have. They are different from each other in following ways. Kinetic energy and potential energy. First point of kinetic energy. The energy which an object has because of its motion is called kinetic energy. Second point. The relation for kinetic energy of an object of mass m and moving with speed v is kinetic energy equal 1 upon 2 mv square. Potential energy. The energy stored in an object because of its specific state of position is called its potential energy. Second point. The relation for potential energy of an object of mass m due to earth gravity, g is acceleration due to gravity, held at a height h above ground is potential energy equal mgh. Third point of kinetic energy. Kinetic energy of an object depends on the speed of the object, so more is the speed, more is kinetic energy and vice versa. And third point of potential energy. Potential energy of an object depends upon the height from earth's surface, so more is height of object from ground, more is its potential energy and vice versa. Fourth point of kinetic energy. When work is done on an object which increases speed the object, work done is equal to kinetic energy gained by object, or we can say work is transformed into kinetic energy of the object. Fourth point of potential energy. When work is done on object to change position of the object against some force, gravitational force of the earth, work done is equal to potential energy gained by the object, or we can say work is transformed into potential energy of the object. Question number 1b. Write detailed answer. Second, derive the formula of kinetic energy of an object of mass m moving with velocity v. Answer. Let us say an object of mass m is moving with speed v, so energy which the object has because of its motion or speed is kinetic energy. Now let us assume object was initially at rest. Some work was done on it to increase its speed to v and it gained kinetic energy. Now from law of conservation of energy, we know kinetic energy will be equal to work done on the object. Suppose F force was applied on a body of mass m initially at rest to increases its speed to v in time t. In this time, object also cover distance s. We know work done W on a body of mass m which moved a distance s due a force F applied on its given as W equal F into S. Also, force applied on the object of mass m moving with acceleration is given as F equal ma. So work done will be W equal ma into S. We have Newton's second equation of motion, which related displacement s covered by object in time t having initial velocity u. With its acceleration equation is s equal ut plus 1 upon 2 at square. Initially object it is at rest, so initial velocity is u equal 0 meter per second. So equation becomes s equals 0 into t plus 1 upon 2 a2 square equal 1 upon 2 a2 square. And then putting value of displacement s, we get work done as w equal ma into 1 upon 2 a2 square. This can be further simplified as w equal 1 upon 2 ma square t square equal 1 upon 2 m at square. Using Newton's first equation of motion, which related final velocity of v gained by object in time t moving initial with initial velocity u with acceleration of the object as v equal u plus at. Initial object is at rest, so initial velocity is u equal 0 meter per second. So equation becomes v equal 0 plus at plus equal 80. Now replace the value of v in above equation to find the work done we get. Okay. W equal 1 upon 2 m in bracket a2 close bracket square equal 1 upon 2 mv square. Now this work done is equal to kinetic energy of the object of mass m moving with velocity v, is that kinetic energy of the object is k kinetic energy equal 1 upon 2 mv square. That's the final answer. Okay. And the next question number 1c, write detailed answer. Prove that the kinetic energy of a freely falling object on reaching the ground is nothing but the transformation of its initial potential energy. Answer. Let us assume an object of mass m is kept at rest initial at the height h above the ground, and the object is suddenly released. So it will gain speed, and let the velocity of object just before hitting the ground be v. Okay. The situation has been shown in figure. Now you can see. Okay. Situation is shown in figure. Okay. Answer. Initial object of mass m was at a height h above the ground, so potential energy of the object is Pe, is that potential energy. Potential energy equal mgh. G is acceleration due to t. Okay. Now when object approaches ground, just before hitting the ground, let the velocity of object be v, so its kinetic energy will be. Okay. Kinetic energy equal 1 upon 2 mv square. Now applying Newton's third equation of motion of the object, v square minus u square equal 2as. Here v is final velocity of object, you know that. Okay. U is the initial velocity of the object, s is the displacement covered by object, and a is acceleration during motion. Okay. And now initially object was at rest, so it is initial velocity. Now u equals 0 meter per second. The object is coming downwards due to gravitational force applied by earth, so its acceleration is a g, is that acceleration due to gravity is that a equal g. Due to acceleration, final velocity of object change to v in moving from height h to ground, so its displacement is s equal h. And putting the values in the equation, we get v square minus 0 square equal 2gh, or we get value of a square of final velocity as v square equal 2gh. Okay. Uh, Now putting the value of v square in equation of final kinetic energy of the object, we get kinetic energy equal 1 upon 2 mv square equal 1 upon 2 m 2g in bracket 2gh. Solving, we get the final kinetic energy of the object as kinetic energy equal mgh. Okay. And initial potential energy of the object is p potential energy, the mgh, potential energy equal mgh. Okay. Now we can see final kinetic energy of the object is the same as the initial potential energy of the object. And since initially object was at rest, so its initial kinetic energy was 0, and finally object was just near the ground, is that its height from surface of earth is 0, so its final potential energy is also 0. This conveys that all the kinetic energy of freely falling object on reaching the ground is nothing but the transformation of its initial potential energy. Okay, your answer was completed. Question number 1 C completed. Okay. Question number 1 D, write detailed answer. Okay. The question is, determine the amount of work done when an object is displayed at an angle of 30 degree with respect to the direction of the applied force. Answer, suppose an object is displaced from its original position due to application of a force which is not to direction of force. Force is making an angle of 30 degree with the direction of displacement. Okay. So situation has shown in the figure, you can see. Okay. So now we know work done on on an object due to force is given by relation. Okay. So here W equal Fs cos theta. Okay, where W is work done due to force, F is displacing object by S, or theta is the angle between force and displacement. Now you can see here. Okay, that's the initially and finally. Okay, so work done will be W equal Fs cos theta 30 degree. Okay, from trigonometry we know value of cos 30 as cos 30 degree equal under root 3 upon 2. So putting the value, we get work done as W equal Fs into under root 3 upon 2 equal under root 3 upon 2 Fs here. Okay, that's the formula. Okay, वर्क डन जब हम जब पुटिंग हम कर देंगे फॉर्मूला को तो वैल्यू यहाँ पे आ जाएगा. ओके, सो amount of work done when an object is displayed at an angle of 30 degree with respect to the direction of the display, the applied force is under root 3 upon 2 Fs, where F is magnitude of applied force and S is the displacement of the object. Okay, answer was answer is completed. Okay, question number 1E, write detailed answer. Question is, if an object has zero momentum, does it have kinetic energy? Explain your answer. Answer, if an object has zero momentum, then its kinetic energy is also zero, is that it does not have kinetic energy. We know momentum of of an object is given as P equal mv. Okay, where P is the momentum of object of mass m moving with speed v. Now P equals 0. Is that mv equal 0? So either mass of object is 0 or its velocity is 0. Is it at rest? Now object will have some mass, let it be m, so its velocity is 0, v equals 0. Okay. Now kinetic energy of any object is given as kinetic energy equal 1 upon 2 mv square, where m is the mass of object moving with velocity v. Putting v equal 0 in the above equation, we get kinetic energy as kinetic energy equal 1 upon 2 m into 0 square equal 0 joule j. So we get kinetic energy of the object as 0 j means joule. So it does not have kinetic energy if momentum of the object is 0. Okay. Next question. Write detailed answer. Question is why is the work done on an object moving with uniform circular motion 0? Answer. In uniform circular motion, work done on an object is 0 because force acting on the object is always perpendicular to its velocity and displacement in uniform circular motion. Number 1, the speed of the object is same throughout, but the velocity is changing because the direction of motion of object is continuously changing. Second, the object is accelerating and acceleration is toward the center of circular path in which object is moving to. Force is also acting towards the center of the circular path is that perpendicular to the direction of motion. The path of circular motion of object, direction of its velocity, displacement, acceleration and force at any instant has been shown in the figure. You can see. Okay. As we can see, direction of velocity and displacement at any instant is along the tangent of circle and its is perpendicular to direction of acceleration, and force is that angle between force and displacement and at any instant is 90 degree. Now we know work done on an object due to a force is given by relation. So formula W equal F into S into cos theta, where W is work done and F is a force displacing object by S, and theta is angle between force and displacement. Okay. Hence let the force applied be F and very small. Displacement at any instant be S, angle between force and displacement is theta equal 90 degree. So work done will be W equal Fs cos theta 90 degree. From trigonometry we know that value of cos 90 as cos 90 is equal 0. Okay. So putting the value we get work done as W equal Fs into 0 equal 0. Okay. And work done on an object moving with uniform circular motion is 0. Our next question. Question number 2a. Choose one or more correct alternatives. First question. For work to be performed, energy must be. Answer option 3. Now you can see. Okay. Transformed from one type to another. Explain. Your choice. Okay. आप लिखना चाहो तो लिख सकते हो, नहीं लिखना है तो your question. Okay, your mind anyway. Okay. क्वेश्चन नंबर 2B, इसमें भी करेक्टेड अल्टरनेटिव्स को चूज करना है आपको. चूज वन और मोर करेक्ट अल्टरनेटिव्स लिखा है ना. ओके. जूल इज द यूनिट ऑफ किसका है आंसर? वर्क एंड एनर्जी. वर्क एंड एनर्जी. ओके. बस एक्सप्लेनेशन आपको लिखना है तो लिख लीजिए. ओके. थर्ड है हमारा, ये भी करेक्ट अल्टरनेटिव्स आपको चूज करने. विच ऑफ द फोर्स इन्वॉल्व इन ड्रैगिंग अ हैवी ऑब्जेक्ट ऑन अ स्मूथ हॉरिजॉन्टल सरफेस हैव द सेम मैग्नीट्यूड. ओके. तो आपको फर्स्ट ऑप्शन है द हॉरिजॉन्टल अप्लाइड फोर्स, सेकेंड ग्रेविटेशनल फोर्स, थर्ड रिएक्शन फोर्स इन वर्टिकल डायरेक्शन एंड फोर्थ है फोर्स ऑफ फ्रिक्शन. तो आंसर हो जाएगा आपका ऑप्शन 2 ग्रेविटेशनल फोर्स, एंड थर्ड है आपका, ये दोनों ही होंगे. ठीक है. एक्सप्लेनेशन आप चाहो तो कर लो वरना नहीं. उसके बाद है आपका ये पावर इज अ मेजर ऑफ आंसर ऑप्शन 1 द रैपिडिटी विच वर्क इज डन. ओके. एंड ऑप्शन 3 द स्लोनेस विथ which work is performed. Okay. And explanation, your choice. Next, while dragging of lifting an object, negative work is done by option 2 gravitational force and option 3 frictional force is right answer. Explanation. Okay. Explanation, all of explanation. Okay. And question number 3A, rewrite the following sentence using proper alternatives. The question is, the potential energy of your body is least when you are option A means 1 sitting on a chair, second sitting on the ground, third sleeping on the ground, or fourth standing on the ground. Which is right? Third is right, sleeping on the ground. Okay. Explanation, your choice. Okay. And question number second, the total energy of an object following freely towards the ground. Option 1 decreases, second remains unchanged, and 3 increases, or 4 increases in the beginning and the decreases. Which is right? Option second. Okay. Remains unchanged. Option second is right. Okay. And explanation. Next, rewrite the following sentence using proper alternatives. Okay. Question number, if we increase the velocity of a car moving on a surface to 4 times its original speed, its potential energy for option first will be twice in original energy, second will not change, third will be 4 times its original energy, and will be 16 times its original energy. So answer option second is right, will not change. Okay. Explanation. Okay. Next question, the work done on an object does not depend on which option is right? So for third is right, initial velocity of the object. Okay. Explanation. explanation why the work done on an object does not depend. Okay. Next question. Question number 4a. Study the following activity and answer the question. Activity first. Take two aluminium channels of the different length. Second, place the lower and the channel on the floor and hold their upper ends the same height. Third, now take two balls of the same size and wait and release them for the top end of the channels. They will roll down and cover the same distance. Your first of all, figure. Okay. Okay, and question uh, related these questions. Okay, this question. Okay, at the moment of releasing the balls, which energy do the balls have? Answer. Now suppose two aluminium channels of different height and placed and incline of the floor such that top of the ball is that same height as shown in the figure. Now, initially both balls are the rest, so they do not have any kinetic energy and both are same height above the floor is that earth's surface, so they will have gravitational potential energy, as we know that the relation for potential energy of an object of mass m due to earth gravity, g is acceleration due to gravity, held at an height h above ground is potential energy equal mgh. Okay. And second question, why do the ball cover the same distance on the rolling down? Same. Your answer? Okay. Next question. What is the form of the eventual total energy of the balls? Answer. Okay. Write in your notebook. Okay. Question number 4e. Study the following activity and answer the question. Okay. Related question. Which law related energy does not above activity? Demonstrate, explain. आपको जो एक्टिविटी दिया गया है ना, उसी का ये 3 क्वेश्चन दिया गया है, ठीक है। उसी के अंदर से आपको ये 3 क्वेश्चन किए बताए कि क्या होगा, तो आंसर होगा यहाँ पे, आप देख लो। ओके। क्वेश्चन नंबर 5a. सॉल्व द फॉलोइंग एग्जाम्पल्स। एन इलेक्ट्रिक पंप हैज़ 2 kilowatt power. How much water will the pump lift every minute to height of 10 minutes? Answer. Final answer is that around the, okay, okay, write down in your notebook. Next question, if a 1200 watt electric iron is used daily for 30 minutes, how much total electricity is consumed in the month of April? Okay, you can see answer. your final answer. Okay, highlighted with pencils in your notebook. Okay, next question. If the energy of a ball falling down from sorry if the energy of a ball falling from a height of 10 meters is reduced by 40%, how high will the rebound? Answer. First of all, situation has been shown in figure C. Okay, and the answer. Okay, important thing. Question number 5 is the most important because coming in exam. Okay, in minimum for 5 marks. And the next question, the velocity of a car increases from the 54 kilometer hour to 272 kilometer hour. How much is the work done if the mass of the car is 1500 kg? Your answer. Answer. Next question. Ravi applied a force of 10 Newton and moved a book 30 centimeter in the direction of the force. How much was the work done by Ravi? First of all, situation in the figure. Okay. Answer here, a book is displaced by 30 centimeter due to 10 Newton force as depicted in the figure. We know work done on an object due to a force is given by relation W equal F. Where W is the work done due to force, F is displacing object by S in the direction of force. Here the force applied is F equal 10 Newton. The displacement of book in the direction of force S equal 30 centimeter. All units should be in SI. That means System of International. Okay, SI. Full form of System of International. So converting cm to m. Okay. So means one centimeter equal 1 upon 100 meter. So we get displacement as you can see in this video. Okay, S equal 30 into 1 upon 100 equal 30 upon 100 m meter equal 0.3 meter. So work done on the book is W equal 10 Newton into 0.3 meter equal 3 Newton. Okay, answer is finally answer is that Ravi did 3 joule work to move the book. Next question, question number 6. Study the various instances of transformation of energy you see around you and discuss them in class. This is the activity, your choice. Okay, want to do or not. Okay, so uh, share our videos, subscribe our channel. Okay, and like our video. Any doubt, say in comment, ask in comment. Okay, okay, and if you want this chapter question answer in PDF form, so check the description box. Okay, and download the PDF form in this chapter. Okay, work and energy. Okay, so bye and take care. Okay, we will coming soon in next video. Okay, your next chapter. So bye and take care.